The topic that we are discussing today is single degree of freedom, undamped free vibration using complex sinusoid. So the idea of this topic is actually pretty properly covered. Like you take up any book, you will find this is already covered. So why I'm repeating this entire thing is that I want to show that what is the use of this e power I omega t plus phi, that is basically called complex sinusoid, and how you can use this for finding solution for vibrations of problems. Like for example, can you use this to find single degree of freedom system, or forced vibration, free vibration. So that kind of thing we are doing. So we are starting with the single degree of freedom system, and that we'll go ahead with the damped, and then we'll go ahead with the single degree of freedom system, forced vibration and all. So this is initial condition over here, so initial position over here. So you see over here, this is a system which has a spring constant k over here, and this is mass m. So because we are writing undamped over here, we are skipping the damped portion, so c we are not writing. So and over here, this is the initial position where the mass is at initially, but then mass m is over here is there because of that gravity, it is coming down. And so basically it is like you are pulling a spring. So initially spring over here, whatever is the condition over here, that is the initial position of the spring. Then by this mass you are pulling the spring. So when you pull the spring will always try to go back, and that is what is happening over here. Spring is trying to go back over here, and that is k delta force which is acting over here. And that is what is the this is what is basically called as static equilibrium position. So this one over here is static equilibrium position, and that is purely because of this mass which is m is lying over there. And then after that, we basically take from a static equilibrium position, we simply try to move it by x downward, and we leave it. And then because initially what we are happening, because we have chosen x to be positive downward, the velocity and acceleration are also positive in that direction. So for this system we are trying to write equation of motions, and then also we are trying to solve them. So that's the idea, that's what we are covering over here. So for the system, if we take there are two approaches which you can take over here. One, you can take Newton's second law of motion. Actually there are many approaches which you can take. I am taking only two over here. So for Newton's second of law of motion, you can say mx double dot is nothing but summation f over here. And that you can see over here, what is summation f, what is the external force which is acting, that is nothing but mg is acting downward, and then you have minus k delta and minus kx. And from static equilibrium position, I know that mg and k delta are equal. That is what is I can see from this static equilibrium position, and therefore I can write mx double dot plus kx is equal to 0, and that is what is the equation of motion over here. Now the same thing I can do it by energy approach. So energy approach I am writing over here. So in energy approach, what we do, we write what is the potential energy and what is the kinetic energy, and we say that sum of the energy will be constant. So that is the potential energy over here. So for potential energy, if we write, we can write it as half k x square over here. And then if you write kinetic energy, so kinetic energy is nothing but in this particular case it will be half m x dot square. And then I am saying that u plus t is nothing but constant. That is the energy approach. So if you take that, then that is nothing but half kx square plus half m x double square is equal to constant. So if I differentiate this both sides, then I will get half into k into 2x, and I'm differentiating with respect to x over here, and this I will get half into 2m and x dot, and over here I will get x dot over here, and I will get x dot and x double dot over here, and this is equal to 0 over here. So you can see this 2 and 2 will cancel out, and this x dot also will cancel out. You can see from here this will cancel out, and so again you are left with the same thing, that is mx double dot plus kx is equal to 0. That is nothing but, so whatever approach you take, eventually you will be left with this. That is what is the equation of motion. This is what we need to solve. if you want to solve this equation, whatever you have got currently, so first you observe this. What is this equation over here? That is basically linear homogeneous second order differential equation. Why it is homogeneous? Because there is no constant term on the right hand side or left hand side, which I can move to right hand side eventually. And it is second order because the differentiation of x is maximum up to x double dot over here. That is what is second order, and it's a linear equation over here. And so to solve it, if I have initial conditions, then I can solve it. So what is the initial condition? Let's say I know the velocity and displacement at time t is equal to 0. So what I know at t is equal to 0, I know velocity, this displacement. So x0 is known, and at t is equal to 0 I know velocity. So x, this is also is known to me. So these two are known to me. So I basically want to find solution of this equation in terms of these two. So let's see how do we find over here. How do we do it over here? So for that, let us see how do we do. So for example, over here, what do we do? Initially, if you see over here, it is very clear that the form the equation is taking over here, and this kind of, we are aware that there is this function e power lambda t, and what is the there is a property of e power lambda t that if you differentiate it, like for example, if I write a function, let's say g of t is equal to e power lambda t, and then if I write g prime t, then that is nothing but lambda e power lambda t, and if I write g double prime t, then that is nothing but lambda square e power lambda t. Because you are getting this e power lambda t again and again in differentiation, eventually this could be a good way of solving it. That is what you can directly see from the observation. So if I assume that x is nothing but e power lambda t, then I can solve the equation easily. That is what is the idea. And so I want to solve this equation over here. Now if I put it over here, I am going to get m lambda square. That's what I have done it over here. E power lambda t plus k e power lambda t is equal to 0. This is what I am going to get. Now what I am going to get from over here, that from over here directly, what I can get over here, that lambda square is equal to nothing but minus k by m. So and then I can write lambda is equal to that is I root k by m. So there, that's how I get this I into picture, where because where I is nothing but root of minus 1. That's the idea. That's how I get it in the picture. So now the idea is I have got this imaginary number over here, and therefore let's say that omega n is nothing, or let's say omega n is nothing but root k by m. That is the natural frequency over here. So I can write the solution. So basically x is nothing but e power I. That's what I've got. Now see, you can see that as you are going to get this plus I over here, you are also supposed to get this plus minus over here, because if you get that plus minus over here, the second solution will be x is equal to e power minus I omega n t. So you have these two solutions where you have this is solution number 1 over here. Let me write it x1, let me write it x2. Let me say it over here that x is always function of t, is just because of the I'm not writing it again and again, but actually it is always function of t. So if you want to write a general solution for it, because both the equations are going to satisfy the equation, then any linear combination of this also will satisfy the equation or will be equation. So general equation I can write is solution, if I want to write that, I can write x of t will be nothing but c1, that is a linear combination of this x1 and plus c2 e power minus omega n. Yeah, so why we started, let me once again stress over here. So you see, there is nothing imaginary about the system. It's the as simple system as possible. You have a spring, you have a mass, and you simply move it from a static equilibrium and it starts to vibrate. There is nothing imaginary over here. But finally, if I choose that solution to be in the form of e power lambda t over here, eventually I am going to get something which is basically having this I omega nt and I minus I omega nt. Then what is this like? How does it coming into picture? So that is what I am going to explain in this video. That is what this video is for. That how this complex sinusoid form would be useful for finding solution. So that's what we are seeing over here. So as we mentioned over here, that I know the initial condition. What was the initial condition? That I know x0. So you can see if I put t is equal to 0 over here, I will get c1 e power 0 and then c2 e power minus 0. So that is nothing but c1 plus c2. So my first equation is c1 plus c2 is equal to x of 0. That is known to me. That's what is the initial condition I have taken over here. That's what I have taken is known to me. Now if I differentiate this equation, whatever I have got this solution, if I differentiate that, I am going to, or and if I differentiate that and simultaneously I put t is equal to 0 over here, then I am going to get this. And then minus 1 is coming from there, minus I omega, let me write over here, c2 e power I omega n minus omega n and 0 over here. Now again you can see over here what is going to happen, that I am going to have this I omega n, and this is c1 over here, and this will become 1, and this will become minus I omega n c2 over here. So that is what I have got. So if I write c1 minus c2, that is nothing but x dot 0 divided by I omega n. Let us say, so there are different, so when you write like this, what does it mean? What does it mean? It is velocity divided by I omega n. So there are physical representations of it, like it is basically something to do with the phase of it. But let's say we don't know all those things. We are simply doing mathematical form over here. We are not aware of that, what does it physically mean and all. We have simply taken it e power I omega t because it was over here. We felt that it will be easy to solve this. That is the reason we have taken it. So let's go in that line, and so I want to find, so I found this c1 plus c2 is equal to x0 over here. So you can see I can solve these two equation, and if I solve this equation, then I will simply get c1 will be, it is, I am not writing all this stuff, that is kind of quite obvious, so I am not doing that. So this is half over here, and c2 will be half x of 0 minus, I hope that it is obvious to you as well that why I am directly writing it. If it is not obvious to you, please solve this equation over here, that is 1 and 2. You solve it, you will get these two. If that is not obvious why I am writing. Actually I am solving only, but I don't want to write the steps over here. So that's what we have found now. Now let us go to yeah, so we have got c1 and c2, and that is also a function of I, that there is also some imaginary function. So basically we want to write this x of t over here, and we are having heavily imaginary form over here. So let's put that c1 and c2 in this equation, whatever we have got over here. Let's rewrite this equation, and so over here what I have written earlier, I have written x of t is nothing but c1 e power I omega nt plus c2 e power minus I omega nt, and c1 and c2 is this. Let's do it. So now xt will be half, and then x of 0, and then x dot 0 divided by I omega, and that is nothing but I have put the value of c1. I have not changed anything yet. And the second form, whatever is over here, let me write it as using the Euler's formula. So I'm hoping that you are aware that e power I theta is nothing but cos theta plus I is sin theta. That is the Euler's formula over here, and that I can write I cos omega nt. So that is just 1 minute. So that is over here cos omega nt plus I sin omega nt, and this is all is the first term. And then the second term, if I write second term over here, let me write over here so that something is below this, and later it will be easy for me, and that is I omega n, and then cos omega nt, and then I have minus I sin omega nt. So you can see I have now 8 terms. Why I am saying 8 terms? There are 2 terms over here and 2 terms over here. That will multiply. That will give me 4 terms. 2 terms over here, 2 terms over here. They will multiply. They will give me 4 terms. So 4 plus 4, 8 terms I will have. So that's those 8 terms I am writing one after another. And so that's let us take half outside. So let's say 2 of xt. So better, because I don't want to write half everywhere, and it is anyway it is there in both the places. So let me write 2 of x of t, so that I will multiply later, and then I will simply multiply the remaining terms. So I will have first term will be x0 cos omega nt, second term will be x0 into I into sin omega nt, third term will be x dot 0 I omega n into cos omega nt, and last term will be this I and I will get cancelled, so I will have x dot 0 divided by omega n, and then I have sine omega n t. Let's see what happens to the this over here. Let's see what will happen. So again I will have, I am having plus over here because that is the something, but this plus over here, so that I am going to write, I will remove it so that nobody confuses it with minus. So that is what is this, so that is x0 and then cos omega nt, that is the same like first term over here. And the second term will be, now over here in the second term there was a plus sign over here, but now here is a minus sign over here, so I will have minus I x0 into sine omega nt, and then I can write the third term, like the third term over here. Again you can see in third term I have minus here, and this one over here is cos omega nt, so that will be minus x dot 0 by omega I omega n and cos omega nt, and the last one there is a minus sign here and there is a minus sign here, they will get multiplied, that will be plus, and that I will get x dot 0 divided by omega n into sine omega nt. So now what you see over here, that this and this will cancel out, and simultaneously this and this will cancel out, so I am left with two terms, like four terms over here, that 2x comma t is nothing but 2 of x naught cos omega nt, and this one over here is x dot divided by omega n into sine omega nt, again twice of that. So now you can see I have 2 on left hand side also and right hand side also, so I can take out that 2 outside, so that x of t I can directly write is nothing but x of o cos omega nt plus x dot o divided by omega n and sine omega nt. That is what is finally I have got. Now I can write it in terms of, I can simply write it as a cos omega nt plus let's say or let's say yeah, so okay, let me write, because I have already written a over here, b sine omega nt. So now what I can do, I can divide this entire thing by root a square plus b square, then I will have something like this, a square plus b square over here, and then I have cos omega nt, and then I will have b divided by root a square plus b square, and that will be sine omega nt. That is what I can do. So now this is nothing but whatever I have got this term over here, that is nothing but I am writing that is x naught, and whatever this term I have got over here, that I am writing is nothing but this over here. So that is what I want to do. So I can divide this entire term by, as I mentioned, see over here a is nothing but x0 and b is nothing but x0 x dot 0 by omega n. So if I can divide it by the root a square plus b square, I can write that as cos something like that, and that obviously I have to multiply, because initially this is the one, so obviously that I have to multiply outside over here, and that I can write something like this, that it is multiplied with root a square plus b square. So if I do that, what I can write over here is, I have some amplitude over here, let me write amp. So amplitude amp is root a square plus b square, and that is nothing but x0 whole square and x dot 0 divided by omega n whole square. And if I assume that amplitude, then what this entire thing is, that can be simply written as, because the first term whatever this a by root a square plus b square, that I can write as cos omega t. So I can write x of t is equal to amp, and that is amplitude, and then cos omega cos phi and cos omega nt plus sine phi and sine omega nt, that I can write as amplitude into cos omega nt minus phi. Now so basically I have to find what is this phi. I know what is cos phi and what is sine phi, so I can find phi. So that if I am doing that, I can find directly phi as tan inverse, and over here I will have x dot 0 divided by x0 and omega n. So that is what I am going to get. and that is what I have done over here. So you see basically I have got this finally x of t in terms of this equation over here, which is some amplitude into cos omega n minus 5 over here. You see there is nothing imaginary about this over here. Everything whatever you're seeing over here is everything is like real over here. So when we started with, that's what I wanted to explain the starting itself. When we started with this e power lambda t, it's more like a tool. So complex sinusoid, what we are starting over here is more like a tool, and eventually it is not coming in the final solution. So whatever final solution is we are going to get, it is very much real. There is nothing about imaginary over here. So that's all I wanted to explain in this video. So I will stop over here. Thank you.